write the strategy over here that gives us this. We want in the end that the that the means, that the data look like the mean say. So the data mean converges to the average of the means in a certain way. So we want some, so we're going to, how to say it? That's, okay. I'll take 5 minutes to tell you the strategy, and then I think there's always bits to point at that will tell you how it works. So, the strategy in the end that we're going to look at is going to be like this. So this is a strategy for investing in this game because it's a sum of those gambles on xi that you were allowed to take. It doesn't invest in the variance option at all. Okay, so what are the steps in the proof? Well, the first thing to show is that Sn squared is roughly a super martingale 2. So the roughly is actually called a semi-martingale. But I won't go into what that means. And we will also have that 1 plus Sn squared is also super martingale. So super martingale means you have a strategy that gives you that. This is a square, so how can that be? Well, that's where the option to invest in the variance comes in. If you expand the square, you see that there will be square terms, and you can buy the square at v. So the v is where the almost actually kicks in. You have to sort of take this v into account. Now we have two super martingales, and they are squares, so they're non-negative. So if we apply our lemma 4, 5, then we know that Sn and Sn squared and 1 plus Sn squared converge. So these things, they don't keep on growing forever. They at some point level off and stop. Okay, that means that if we look at S, that's actually Sn squared minus 1 plus Sn squared. Let's see if I got the minus right. Now I probably want to flip it. So we need to divide by 2, get rid of the cross term. So if you expand the square, you get an Sn squared, you get a 1, and you get twice Sn. So by dividing by 2, I get S back. So this says S looks like the difference between Sn squared and Sn plus 1 squared. So if these two guys converge, then Sn also converges.
Sorry, the square outside of the brackets?
Yes. Sorry. Yeah. So now we have that Sn converges. Sn was this. So that means that sum over x I over I goes to some number. And then from this, we finally get, so this is called Kroneker's lemma. So we won't go into it, it's written in the book, but it really says if you have this, then the only thing that can actually happen at that point is that the average over time is 0. Alright, so the heart of the proof really is this up down, up-crossing exploitation. If it happens, then you get infinitely rich. Then there is some ingenuity in what actually, exactly which super martingale you apply it to. And I can sort of, after reading it, I can see that it works, but I'm still not sure I can come up with it from scratch. But if you just apply it to those two, you get the result. Good. All right, so that was the things I wanted to say. So we did the unbounded case, which is this one. It's very similar to the measure theoretic one that you see, where people make assumptions on the variance to show that this happens with probability 1. You need less assumptions, so that's good. And the way that that pops up is that you only have to price two things, this variance and this mean, instead of everything, which is what a measure would do for you. It would give you a price for every possible function of the data, an expectation if you want. Right, so at this point it is very, very weak in what you need to know. You just need an M and a V in the end. So in the homework I ask you to look at the upcrossings, show actually these two things, that you do get infinitely rich and that it's safe. And you also have a look at exactly what this thing is approximate. Try to make it not very difficult, but I got feedback from Tom that it wasn't trivial either. So I tried to make it not harder than last time. So I hope it worked. If not, then I think I want to know, because then I really have to do something. Alright, that's it. The next one is on Friday, and we'll look at the law of the iterated logarithm. So that's a statement that says what's happening on the way to making this mean 0. And it will tell you sort of bounds on how the process looks on the way to shrinking towards 0 if you take